Part of this question is a little bit more straightforward. It's just in terms of a heating element. The power rating of the heating element is 1 kilowatt, and we're looking for the correct fuse. First thing that I would suggest here is this 1 kilowatt. Okay, you need to be very careful with that. That 1 kilowatt is equivalent to 1000 watts, and you need to have some way of picking that up right at the start of this question. I'd always suggest whenever you see kilowatts that there's some sort of alarm bell rings inside your head to tune you into the fact that you need to change that. So we need to change that 1 kilowatt to 1000 watts. What's the correct fuse then? Well, we're trying to work out here, we've got a power and we've got a voltage, so the equation that relates power and voltage is P equals IV, and that will allow us to work out the current. So that means that 1000 is equal to I times 240. So I is equal to 1000 divided by 240, and that turns out to be I is equal to 4.16 amps. The fuses that we have available are 1, 3, 5, 10 and 13. 1 and 3 are no good because they would blow straight away, because 4.16 amps is bigger than that. 5 amps is the next biggest value of fuse that we have, so 5 amps is the appropriate one to choose there. So we would choose a 5 amp fuse. 10 amps and 13 amps aren't appropriate because they are too big and they would never blow unless it was a really extreme situation that arose. Next part of the question deals with few terms that we need to be able to explain. So in terms of energy and charge, explain what is meant by voltage. Well, voltage by definition, voltage is equal to the energy per unit charge. So voltage is the energy changed per unit charge in a circuit. Now that's generally speaking the energy that's changed from electrical to other forms, but for one mark here we just need to say it's the energy changed per unit charge in a circuit. When the heating element is switched on for a time, the total electric charge that passes around the circuit is 5 coulombs. How much electrical energy is used in this time? This one I think is the easiest equation to remember of them all. E equals ITV. The energy is equal to the current times the times the voltage. So when the heating element is switched on for a time, the total electric charge that passes is 5 coulombs. How much electrical energy is used in this time? Well then, 5 coulombs, that's Q equals IT. So we have E then is equal to 5 times, and it was 240. So 5 times 240 equals 1200. So the electrical energy change there will be 1200 joules. E equals ITV, but E is also equal to Q times V. That's voltage is equal to energy per unit charge, so energy is equal to charge times voltage. So you could use that equation. It's more likely that it's this equation, but you should remember that Q, the charge, is equal to I times T. Explain in terms of electrons the difference between a positively charged object and a negatively charged object. Right. A positively charged object, and because we have to explain the difference, we need to explain both of them. So a positively charged object has lost electrons, and so has more positive charge than negative charge. A negatively charged object will have done the opposite to that, and so it must have gained electrons. And there are 2 marks, one for saying that it's lost electrons for positive charge, one for saying it's gained them for negative charge. Okay, so a positively charged object has lost electrons, a negatively charged object has gained electrons.